Okay, lesson 1.3. Today we need to talk a little bit more, like we're going to be doing over several weeks here, with radicals and with exponents. Today we're going to have radical expressions and how do we simplify them when we need to add and subtract them, okay? So keep in mind the radical sign, what you see here, when you see it by itself, it means square root, okay? These are equivalent. You know, when you see the 2 there or without the 2, those mean the same thing. But anytime you see something else, that's where you're going to see cube roots, fourth roots, fifth roots, okay? From a terminology standpoint, the little subscript, superscript that you see here, this is your index. What's under the radical sign is called your radicand, okay? So if you look at something like this, y equals the nth root of x, that means that there's a number y you can multiply by itself n times and get x. Y to the nth is equal to x. So some of these, like I said, are very straightforward to evaluate. Square root of 25 without a lot of work, that's 5. Cube root of 8, that's 2. Fifth root of 32, that is 2. Okay, so those are pretty straightforward because they all evaluate to rational numbers. Now in some of these you're going to have irrational numbers. You would need a calculator to approximate this. Square root of 2, that's going to be about 1.41, something like that on your calculator. So for our purposes, the exact number is square root of 2. So we need to leave it like that. Cube root of -5, you know, there's nothing I can really do with that other than get an approximation. The fifth root of 3. Okay, but there are times when I'm going to need the ability to simplify what's under the radical. We did a little bit of this last semester, but we're going to go a little bit further here. To simplify the square root of 50, okay, the key to this is to rewrite this as the square root of 2 times 25, okay, because with square roots, I want what's under the square root. I want the radicand to be a perfect square. 25 is a perfect square. So I can write this as 5 times the square root of 2. And that's as simple as that can be. That it is an exact number. So we will not be using any calculator approximations. 5 square root of 2 is the simplest form for this number. Now, if you didn't automatically go to this, okay, what you need to do is you need to have a process. I know that 50 is an even number. I can divide it by 2, okay? 25 is not even. I can't divide it by 2. I can't divide it by 3 or 4. I can divide that by 5. So I know that 50 can be written as 2 times 5 times 5. That's where my perfect square comes in. So the square root of 5 times 5 is going to be 5. So you need to get in the habit of being able to break down any of these large numbers to take square roots. So for example, what if I had the square root of 202? Well, I know that's an even number. So when I divide that by 2, I get 101, okay? 101 can't be divided by 2. It cannot be divided by 3 because the numbers, when you add the numbers 1, 0, and 1, you get 2. It's not a number by 3. Cannot divide by any even number. So this is a prime number. So this one can't be simplified any further. So this is the square root of 2 times 101, but there's no perfect square here. So this one, there's no further simplification for this one. But if I had, say, the square root of 212, then what would my process be? You divide 212 by 2 and you get 106. Divide that by 2 and you get 53. So this can be written, this is 4 times 53. So this is the square root of 4 times 53, which is 2, square root of 53. Okay, so being able to break things down to prime factors is going to be key in simplifying these radical expressions. The cube root of 54x to the 4th. Okay, now instead of a square root, I've got cube roots. So really what I want to do in order to simplify this, I would love for what's under the radical to be perfect cubes. Okay, so let's look at 54. 54 can be divided by 2. That gives me 27. 27 can be divided by 3, which gives me 9. 3, which gives me 3. So it tells me that 54 can be written as 2 times 3 cubed. So that's a perfect cube, okay? So, another way of thinking about this is 2 times 27. So I can rewrite this as the cube root of 2 times 27, and I'm going to write this as x cubed times x, okay? The reason I'm doing that is because I'm taking the cube root. So what's the cube root of 27? That's 3. What's the cube root of x cubed? What number can you multiply 3 times and get x cubed? That is x, okay? So 3x. So what I've been able to do, I've been able to simplify those are perfect cubes. What is left under the radical that's not a perfect cube is going to be the cube root of 2x. So that is the simplest form, 3x times the cube root of 2x. Okay, so again, the key is looking at the numbers, looking at the exponent, trying to organize everything into perfect cubes. Let's look at the square root of 100, x to the 4th. Okay, two things going on, the number and the variable. What's the square root of 100? That's 10. So this is 10 times the square root of x to the 4th. Okay. Now, a couple ways of doing this. You could say, well, let's convert this to exponents. This is 10 times x to the 4 to the 1/2 power. That's 10 times x to the 4 over 2. That's 10x squared. Another way of doing this would be once you got to this spot to say this is the 10 times the square root of x squared times x squared. Okay? Square root of x squared, x. Square root of x squared is x. So this is just 10 x squared. Either way, you're going to get to the same number. 150 x to the 6th. So take 150. I know it's even. Let's divide it by 2. And I get 75. That can be divided by 5, and I get 25. 5 and 25. Okay. Excuse me. 5 and 5. So that tells me that, okay, I'm looking for perfect squares. So it looks like this is going to be 2 times 5 times 5 times 5. What's that? 10 times 25. So this is the square root of 10 times 25. Why don't I write this as x squared times x squared times x squared? That's what x to the 6 is, okay? So I'm looking for square roots. The square root of 25 is 5. The square root of x squared is x, and I've got 3 of those, okay? So it looks like what's left under the radical is going to be times the square root of 10. So 5x cubed times the square root of 10. The cube root of 750 x to the 7th. So 750. I know it's divisible by 2. So that gives me what? So that's 350 plus 25. That's 375. That's divisible by 5. And that will go into there 75 times, divisible by 5. 25 divisible by 5. So it looks like this is going to be back up, there's a little bit of mistake here. When I divide 5 goes into 75, that is what it goes in there 15 times, right? So 15, divide that by 5, and I get a 3, okay? So it looks like this is 2 times 3 times 5 times 5 times 5. Since I'm taking cube roots, I would love to have a perfect cube. So it looks like I do have a perfect cube there in 5 cubed. So this is going to be the cube root of 2 times 3. Now you can write this several ways. 5 times 5 times 5. And then I can write what? X cubed x. That's x to the 7th. The reason I write all of this out is because now it helps me know what's a perfect cube. That's a perfect cube, that's a perfect cube, that's a perfect cube. Okay, so what is the cube root of 5 cubed? That's going to be 5. Cube root of x cubed, that's x. How many of those do I have? I have 2 of those. And then what's left? Under the radical, I'm left with the cube root of 6x. So 5x squared times the cube root of 6x. The fifth root of 96x squared. So let's start with 96. That's divisible by 2, which gives me 48. Divisible by 2, which gives me 24. Divide by 2 to get 12. Divide by 2 to get 6. Divide by 2 to get 3. So count them up, 1, 2, 3, 4, 5. This is 2 to the 5th times 3. Well, I'm in luck because this is the 5th root. So this is the 5th root of 2 to the 5th times x squared times 3. So what's the 5th root of 2 to the 5th? That's 2. And then I'm left with the 5th root of 3x squared. 2 times the square root of 108k squared. So 108. All I know right now is an even number. Divide it by 2 and I get 54. Divide that by 2 to get 27. Divide that by 3 to get 9. Divide by 3 to get 3. So it looks like this is what? 2 squared times 3 squared times 3. So this is 2 times the square root of 2 squared times 3 squared times 3 times k squared. Square root of 2 squared is 2, so I'm going to have 2 times 2. Square root of 3 squared is 3. Square root of k squared is k. And then what's left under the radical is just the square root of 3. So this is 12k times the square root of 3. Square root of 200 m to the 4th n. So 200. What you could recognize, you could just write that as 2 times 100, and you know that's a square root, okay? If you didn't see that, do what we've always been doing here. It's even. Divide it by 2, you get 100. Divide that by 2, you get 50. Divide that by 2, you get 25. Divide that by 5, and you get 5. So this is 2 times 2 squared times 5 squared. So I've tried to organize these into perfect squares because of that square root. So this is 2 times 2 squared times 5 squared times m squared n. That's m to the 4th n. So perfect square. Square root of 2 squared is 2. Square root of 5 squared is 5. Square root of m squared is m, and I have 2 of those guys. What's left? What's left under this radical is the square root of 2n. So this is 10 m squared times the square root of 2n. Cube root of negative 32 x to the 8th y to the 7th. Okay, so if I look at this, cube root of negative 32. So let's look at this. 32, if I divide that by 2, I get negative 16. Divide that by 2, I get negative 8. Divide that by 2, I get negative 4. Divide by 2, I get negative 2. So this is, that's negative 2 to the what power? 1, 2, 3, 4, 5th power. Now another way of thinking about this is the negative confuses people. To write it like this, and this may be a simpler way. Write this as the cube root of negative 1 times 32 x8, y 7th. What's the cube root of -1? What number can you multiply 3 times and get a -1? Cube root of -1 is 1. So let's just write this as negative 32 x to the 8th, y to the 7th. Okay, so we know that 32, so that's going to be 2 to the 5th. So I'm going to have 2 cubed times 2 squared, and then x cubed, x squared, and then y cubed, y. Okay, that's x to the 8th, y to the 7th. The reason I do this is because I'm taking cube roots. So don't forget that, cube roots. So everything that's a perfect cube will come outside of the radical, okay? What's the cube root of 2 cubed? That's 2. What's the cube root of x cubed? That's x, and I got 2 of those. What's the cube root of y squared? That's y, and I've got 2 of those. And then what's left under the radical? What's left under the radical is 2 squared, so that's 4, and I'm left with an x squared y. So negative 2x squared y squared, cube root of 4x squared y. It doesn't look simpler, but this is the simplification of this original problem. So you take everything that's a perfect cube outside of the radical. Looking at the next one, the 4th root of 32x to the 5th. So remember that this is the 4th root. 32 is 2 to the 5th. Another way of writing that is 2 to the 4th times 2 to the 1st, right? So this is 2 to the 4th times 2, x to the 4th times x. Fourth, so the perfect fourths here are right there. 4th root of 2 to the 4th is 2. 4th root of x to the 4th is x. Now, what is left under the radical? 4th root of 2x is left. So 2x times the 4th root of 2x is the simplification of this guy. Now, that's a big key skill, simplifying radicals. You need that skill to be very solid when you come to doing multiplying and adding of these expressions. So what we want to carry on now is when you see something like x plus 2x, so x plus 2x, you know that's like 1 apple plus 2 apples. You add them together, you get 3x, okay? X minus 5x, that's 1x minus 5x, that's minus 4x. X plus y is x plus y. Those are unlike terms. You can't simplify them. Same thing happens with radicals. If you had 1 times the square root of 5 plus 2 times the square root of 5, that is 3 times the square root of 5. If you had 1 times the square root of 13 minus 5 times the square root of 13, that's negative 4 times the square root of 13. If you had the square root of 2 plus the square root of 5, you still have the square root of 2 plus the square root of 5. You cannot combine these. They're unlike terms. This is not the square root of 10, okay? So you can only combine them if they're like terms. So let's simplify and evaluate. 3 square root of 2 plus 3 square root of 2 minus square root of 2. So this is 3 plus 3. This is 6 square root of 2 minus 1 square root of 2. This is just 5 square root of 2. 2 square root of 6 minus 3 square root of 6 minus 2 square root of 6. So 2 minus 3 is negative 1. Negative 1 minus 2 is negative 3. This is negative 3 square root of 6. Now here, I can't add these together right away. I'm going to have to see, can I simplify? So square root of 2, that's about as simple as that one can get. So let's look at this. What about the square root of 8? So the square root of 8, that's the square root of 2 times 4, which is 2 square root of 2. And then the square root of 18, that's the square root of 2 times 9, which is 3 square root of 2. So what I have here, I've got 2 times 2 square root of 2 plus 3 square root of 2 minus 2 times the square root of 18 is 3 square root of 2. So I had to do a lot of simplification to get it, but now I see every square root is a square root of 2. So this is going to be 4 square root of 2 plus 3 square root of 2 minus 6 square root of 2. So this is going to be 7 minus 6, which is 1 square root of 2. So that's your answer, the square root of 2. Three square root of 18 plus 2 square root of 5 minus 2 square root of 2. So your key is going to be write this as 3 times the square root of 2 times 9 plus 2 square root of 5 minus 2 square root of 2. The square root of 9 is 3, so this becomes 3 times 3 square root of 2 plus 2 square root of 5 minus 2 square root of 2. This is 9 square root of 2 plus 2 square root of 5 minus 2 square root of 2. The only thing that can be combined now is this square root of 2 term. So that is 7 square root of 2 plus 2 square root of 5. And that's as far as I can go on that guy. Simplifying, 3 times the cube root of 48 minus 2 times the cube root of 162. So the key here is I've got cube roots. Can I organize what's under the radical into perfect cubes? So 48, if I divide it by 2, I get 24. Divide it by 2, I get 12. Divide that by 2, I get 6. Divide by 2, I get 3. Okay, so I want to organize as perfect cubes. So I've got 1, 2, 3, 4, 2. So I could write this as 2 cubed times 6. Okay, that's 48. So that is 8 times 6. If I look at 162, so 162, divide that by 2, you get 81. Divide by 3, you get 27. Divide by 3, you get 9. Divide by 3, you get 3. Can I get perfect cubes? Yes. So this is going to be 6 times 3 cubed. 6 times 27. So it looks like I can write this as 3 times the cube root of, what is this, 8 times 6 minus 2 times the cube root of 6 times 27. What's the cube root of 8? That's 2. So this is 3 times 2, cube root of 6, minus 2. Cube root of 27 is 3, and cube root of 6. So this is 6 cube root of 6 minus 6 cube root of 6, which is 0. Okay? Look at the next one where we've got cube roots once again. Okay, let's look at this problem that is remaining here with the cube roots of 40. So if you look at this, one of the big simplifications here, cube root of 40, cube root of 40. So what's negative 3 cube root of 40 plus 2 cube root of 40? That's negative cube root of 40 minus 2 cube root of 6. 6 is just 2 times 3, so I really can't simplify that any further. But 40, I can simplify. Divide 40 by 2, you get 20. Divide by 2, you get 10. Divide by 2, you get 5. 40 is 2 cubed times 5, or 8 times 5. So this becomes negative of cube root 8 times 5 minus 2 cube root of 6. Cube root of 8. Cube root of 8 is 2. So this is negative 2 cube root of 5 minus 2 cube root of 6. So negative 2 cube root of 5 minus 2 cube root of 6. Cube root of 48 plus 2 cube root of 135 minus 3 cube root of 5. Cube root of 5, that's about as far as I can go. So let's look at cube root of 48. 48 divides by 2 and you get 24. Divide by 2 and you get 12. Divide by 2, you get 6. Divide by 2 and you get 3. So cube roots, yes. So I can look, this is what, 8 times 6? So 8 times 6, that would give me a perfect cubed. And if I look at 135, I know I can divide that by 5 and get a 27. I can divide by 3 and get 9. Divide by 3 and get 3. So this is 5 times 27, which is a perfect cube. So what I have here is negative cube root. 48 can be written as 8 times 6 plus 2 cube root. 5 times 27 minus 3 cube root of 5. So perfect cubes. Cube root of 8, cube root of 27. What's the cube root of 8? That's 2. So I get negative 2 cube root of 6. And then perfect cube 27. So plus 2 times 3 cube root of 5 minus 3 cube root of 5. So this is negative 2 cube root of 6 plus 6 cube root of 5 minus 3 cube root of 5. 6 minus 3 is 3, so this is negative 2 cube root of 6 plus 3 cube root of 5. And that is it for 1.3. You have homework in this, and we will take a look at this when I see you guys next.